Hey everybody, so today I'm going to be talking about Compatibility Matrix, which is a new service that we're working on here at Replicated, and the subtitle for this talk is Testing on Customer Representative Environments. So a challenge of deploying on-prem is that every customer environment is unique. So Kubernetes is supposed to help with this, and it does help to a certain extent. Kubernetes is an infrastructure abstraction that supposedly lets you run your applications anywhere. But in practice, we know that different Kubernetes distributions and different versions work somewhat differently. So let's say you start with your application and you start delivering this on-premise to your customers, and they have different Kubernetes distributions. So your first customer is with GKE, you test that, deploy it, works great. Then as you start adding new customers and deploying to new environments, there starts to be some more variance. You've got people on EKS, people on OpenShift, customers on AKS, Tanzu, other distributions. And then on top of that, you've got all these different versions that different customers are running. So you've got different Kubernetes versions, you've got different OpenShift versions, which they have their own versioning that wraps a Kubernetes version. So you've got all that variance there. And then for each of these different customer environments, they each have their own configuration. They've got their own license entitlements. They've got their own security requirements. So you end up with all of this difference. So when you start out, you hope that this circle is the Venn diagram of your customer environments, that everybody's the same, you test it, it deploys, it's great. But inevitably, as time goes on, you deploy to your second customer, there's a lot of overlap, but there's a little bit difference. And then you add additional customers, and over time, you realize this Venn diagram looks kind of crazy, and the overlap of all these circles is a lot smaller than you wished, and the unique things about each environment is a lot bigger than you wished it was. So testing in these cases becomes very important because there's not just one thing you can test. You want to test for all of these different things, at least as best you can. So how well do you test your on-premises software application? Well, there's lots of obstacles to good testing. You need infrastructure for testing, which can be expensive to keep and maintain. Good testing requires automation in order for it to be scalable, and that automation requires a team to build it. So a lot of the times, teams will end up manually testing their common scenarios because that's good enough, or because it's all that they're able to manage with the size that they are, the team that they have, et cetera. So this leads us to a few different questions we can assess to see how well are you testing your application for deploying to your customer environments. So the first question is, what is it that you test? So do you test kind of a basic installation of your application? Or do you maybe test a couple different common configurations that your customers might have? Or do you test truly customer representative configurations, entitlement values, and things like that? The second question is, where do you test? So do you test a subset of the Kubernetes distributions and versions that you support? Do you support every distribution and version that you support, which would be great? Or even better, do you test on truly customer representative environments? Third question is, when do you actually test? Do you do testing right before a big release? I've actually talked to a number of our customers who are in this boat, and they have sort of 3 days or a week leading up to a big release where they do all their testing. And inevitably, the problem then is even if you catch something, you've got a short time frame to fix it, turn it around, get that into the testing, and then start your testing basically from scratch again. So maybe a little bit better, you do some early testing, but you still have a lot of testing that happens right before a release. Or ideally, you're continuously testing. Every time you're making changes, every time you're releasing, you've got tests that have run automatically that are building your confidence. And then finally, how do you test? So do you do all of your testing manually? Do you have some automation, but you still end up with a lot of manual testing? Or are your tests fully automated, which would obviously be the ideal case here? So in answer to all of these different questions, we're introducing a service called Compatibility Matrix. So Compatibility Matrix is a new service from Replicated that provides programmatic access to test clusters of various Kubernetes distributions and versions in a matter of seconds or minutes in the worst case, depending on the distribution. Some things like OpenShift take a little bit longer to come up, but in general, in a matter of seconds, you can get access to these test clusters with different versions and distributions of Kubernetes. So what are the features of Compatibility Matrix? Well, to touch on just a couple of the key ones, It has support for an increasing number of Kubernetes distributions and versions, so you can test on a wider and wider array of distros and versions. The clusters have TTLs, so they expire automatically if they're not deleted sooner. And there's per second billing with some amount of usage included per account. So you only pay for what you use, and it's much like a cloud provider, just paying per second depending on how long those clusters last. And again, they have TTL, so they'll expire. But if you are done with it, you can manually delete it as well. There's different types of clusters within the compatibility matrix. So we have VM-based clusters. These are hosted on our own bare metal servers. And with these, you're able to choose the amount of vCPUs and memory and disk that you want the nodes of each cluster to contain. And right now, we support kind and K3s distributions with versions 124 up through 127 of Kubernetes. And then we're working on and have upcoming support for OpenShift and curl and RKE2 and K0s. Then on the flip side, in addition to VM-based clusters, we have cloud-based clusters. And these are hosted by major cloud providers with common machine types supported for each one. So if you're using EKS, then there's going to be common instance types for EC2 that are available to use for these clusters. Right now, we support EKS and GKE, and then versions 122 up through 127 are supported for both of those. And we have upcoming support for Azure for AKS. So let's start with a demo of a CLI that we've introduced to manage these clusters. So the replicated cluster subcommand is new here, and I'm going to use replicated cluster create to create my first cluster. So I'm going to give it a name. Let's call it Alex RepliCon. Oh, wait, that's not the name. There we go, Alex RepliCon. Distribution, let's make this an EKS cluster. Version, I'm going to go with 125. And then the default TTL is 1 hour. Let's say I want this one to be available for 2 hours. So right now, this is going and starting to provision an EKS cluster for us. If you're familiar with EKS, if you've provisioned clusters on Amazon before, then you probably know that an EKS cluster takes anywhere from 10 to 20 minutes to create. So it's not a particularly fast process. One of the nice things about the replicated cluster commands on the CLI is that you can use these test clusters for development or support situations. So let's say you're developing a feature and you want to test it on an EKS cluster or an OpenShift cluster. You don't have to have one lying around. You don't have to go to AWS and spend 20 minutes waiting for one to spin up. You could come straight to replicated, create an EKS cluster in a matter of seconds. This one's probably already ready, actually. And then you can do your development on it for as long as you need and delete it when you're done. Or if you're on support and you want to recreate an issue to debug it, and you want to do that on the same distribution and version of that cluster where it occurred, you can come to replicated, get that exact distro and version, recreate the issue, find the root cause, and delete the cluster when you're done. So I'll use the replicated cluster ls command to list my clusters and see what the current status of them is. So this should be the only cluster that I have right now. So it should pop up in just a sec. And we can see it's running. So it's been running for a while probably, but like that was only a minute or two that I was talking. So in at least that time, in reality, it was probably 30 seconds, I had this EKS cluster available instead of the 10, 15, 20 minutes it would normally take. Then, if we have a cluster, we want to use it. So we have this replicated cluster kubeconfig command. I'm going to pass it the ID of this cluster. And this is going to download the kubeconfig for my EKS cluster so that I can actually start using it. So we'll notice here, this is my Kubernetes context here. So I'm targeting an Alex guestbook cluster. We'll see that now that I downloaded that context, it changed to this compatibility matrix cluster. And I can go ahead and get the nodes for this EKS cluster. Cool, I'm on this version of EKS. I've got one node. It's been up for 62 seconds, etc. So super easy just to go create a cluster, use it for what I want. And then when I'm done, I just copy that ID again. And I could either let this cluster expire in 2 hours, or I could go ahead and just manually remove it just like this and be on my merry way back to whatever I was doing before. So that's the replicated cluster CLI commands, which are great. But ultimately the goal of the compatibility matrix as well is testing with it. So we're all about enabling automated testing using the compatibility matrix. Ideally, you'd create some test clusters, run tests on those clusters, and then gain confidence that your application is going to work on the variety of different environments it might be deployed on, and do all of that automatically. So let's talk about smoke testing, for example. So let's say you're a developer and you're working on a feature branch in Git. And you commit some changes and you push that feature branch up to GitHub, let's say, or whatever your Git provider is. And you want to make sure that that is still running. This might not be, comprehensive testing that everything is working, but you want to run a smoke test just to say, hey, is this thing getting packaged appropriately? Is it going to deploy appropriately on Kubernetes and come up and just do a quick test that everything's running? So then on every commit, I can get that feedback. Cool, this is still working. Playing into that continuous testing idea. So with the compatibility matrix, you can commit to your feature branch, and that's going to trigger a replicated release getting created. You can then, it'll promote that release to a feature channel based on the feature branch that you're using, and then automatically kick off the creation of a few different clusters for the smoke test. So in this example, I'm going to use kind, and I'm going to test it on the latest versions of Kubernetes 125, 126, and 127, because that's what my app supports right now. And so compatibility matrix is going to spin up these 3 clusters. It can deploy your application onto those clusters, run your smoke test to make sure everything's good, everything's fine and dandy, and then delete those clusters, clean up the channel, all that kind of stuff when you're done. And then you have that as a check before you actually go and merge your PR and move on to your next feature or whatever it might be. So let's see a demo of smoke testing. So I've got an application here. It's just a simple Nginx application. I'm on a branch that I created called RepliCon. So this is my feature branch. And let's go ahead and make a change to this app. So I'm just going to go into the values YAML for my chart. And let's say change the replica count from 2 to 3. I want 3 replicas of Nginx now. So commit that change, update values YAML. And then, let's say I'm cool with that. I want to open a pull request. Come up here, start my pull request. So I can see I've got a compatibility matrix check that's already running as a part of this commit and this pull request. So if I go back and we'll let that run, it'll take just a minute to finish. But if I come back to my GitHub workflows, I've got a development workflow that is useful in this case. So this is going to happen on pushes to any branch that's not my main branch, so any feature branch that I'm working on. And then I'm going to run some stuff for compatibility matrix. So these initial steps are just specific to my application. So this would be specific to your app. I'm defining a version for the app, using the git SHA, packaging it for replicated, updating my Helm chart kind. This is all just stuff that would be specific to whatever app it is you're using. What's interesting here is down here, these 15 lines of YAML, which define the smoke test that I want to run. So in this case, I'm using a replicated smoke test action. Just have to give it my app slug and my API token, the directory where my YAML is so that I can package this up for a replicated release. And then I've got a Kubernetes distribution and version. So this is done dynamically using what I define up here. So in this case, I'm going to run this on a kind version 125.3 cluster. Ideally, I'd probably do this on a couple more versions. I'm just doing it on one for the sake of the demo, but this is where I can pick, what do I want to smoke test on? Just a couple different versions to make sure things are working well. My installation method's Helm. I've got a test script to run for the smoke test, the chart name, values, just some stuff to get the chart deployed successfully in the first place. So these 15 lines of YAML are all you need to start running smoke tests using compatibility matrix. So if I head back here, I've got my check. It's running. It's still in progress. It should finish up in just a sec. So we can click in here. Oh, there we go. Just finished. So if I come in here, I can see that it did run one job here, kind. It's truncating it, but this is on version, it's up here, version 1.25.3, like I specified. So I've got all my normal steps that were for packaging. Then I got my smoke test. And, obviously the output it's logs, so it's not the easiest to follow, but basically we're just creating a customer, creating a channel, creating the cluster, the kind cluster that we need, doing a Helm install right here, then using our test script to run the test and make sure everything's working. And then there's some cleanup at the end just to archive the customer and archive the channel. And that all happens automatically as a part of this smoke test action that we created at Replicated. So cool, that passed. So I know this thing is getting packaged right, it's deploying right. So I can go ahead and just merge this pull request in to my main branch because I have confidence it's working. Delete the branch, we're all set. Now what I might want to do is cut a release because I've got some new code in main. We're ready to move to our release stage. So let's go back here to releases and let's create a new release. So my next version would be 0.0.20. So let's create a new tag for that, v0.0.20, and publish this release. So it's going to create a new tag and this release. So we'll come back to this in a sec, but I just wanted to kick this off so that it'll be ready for the demo when we come back to it. So in addition to smoke testing, we want to do release testing as well. So maybe in this case, we want to test on the different Kubernetes distributions and versions that our application supports. So when I create a tag, that's going to kick off the creation of a release. That release gets promoted to my beta channel. And then the compatibility matrix is going to automatically create clusters for the different distros and versions that I support. So maybe some versions of GKE and AKS and EKS and OpenShift, and run my tests there. And then all of those results are going to get sent to the vendor portal. This part is still in progress. I won't show it in the demo today, but we're going to take all those results from the compatibility matrix and put them in the vendor portal. So you could go to a release and see, okay, cool. So this release is working on GKE, but it has an issue on OpenShift. And then you'd be able to note that, find the issues, fix them, et cetera. So visualizing all of that within the vendor portal so you can see what the compatibility is of a particular release against the different clusters that you tested it on. But what would be even better than release testing? Customer representative testing. So it's great to test on the distros and the versions that you support, but what if you could test on clusters that are even more representative of your actual customers? Well, Replicated is here to help with that. So we have a feature called Instance Insights that you might be familiar with, and you might have seen this in the vendor portal, where basically for all of your customers, we know what Kubernetes distribution and version they're running. We know the cloud provider or region that they're in if they're using a cloud provider. We know the version of your application that they're running, and we know the installation method and version, like they're using COTS and they're on version 1.99 or something like that. So basically like COTS or whatever replicated component you're deploying with your application into their environment is able to report that information back, and you can visualize that in the vendor portal. And that's useful for a bunch of things we won't get into today, but it's also true for air gap. You're able to use support bundles now to get this information for even your air gap customers. So we have this increasing swath of data about your customers and what their clusters look like. And so here's an example, just a screenshot of what that looks like for 2 customers in the vendor portal. I can see, oh, this one's on AWS. They're using EKS version 127. This is the version of my app that they're on. This one is on K3S version 126. They're on COTS 1.100.2. That's the version of the app. So we've got this information. So we want to leverage that to help you to create truly customer representative environments in the compatibility matrix. So for now, we're calling this Canary testing, being able to actually kind of, in a sense, roll out your application to your customers or just some subset of your customers through the compatibility matrix with these really customer representative environments. So this looks a lot like the release test, but the difference is that after we promote to the beta channel, the compatibility matrix can get all those customer instances from the vendor portal and say, well, you have a customer that's on 1.26.3-GKE.100. You've got a customer on OpenShift 4.13 and AKS 124. And furthermore, we know the license for those customers, so we know what entitlements they have. So we're able to have all this information to help recreate these environments accurately so that you can run tests against those. And again, send all those results back to the vendor portal. So this is like that release test, but it's a step better because it's not just, here's some generic stuff that I support. It's, what are my customers actually running? And hypothetically, in this Canary test, you could also deploy your application version and COTS version into that environment. So if I know this GKE customer is on COTS 187 and they're on my version 1.2.3. I would install those first, run an upgrade to my latest version, and I know not just that my version works on that environment, but that an upgrade from their current state would work on this environment as well. So let's look at some customer representative testing with this Canary testing option. So I created that release so that the creation of that 0.0.20 tag kicked off a workflow. So we'll go into here, look at our release workflow. And so anytime I push a new tag, I'm going to start by getting my customer instances. So basically, this is an action we created that's going to call out to the vendor portal and populate a matrix of customer instances. So in this case, what Kubernetes distros and versions are they on? Then down here, a lot of this is going to look the same. We have to define the app version and do all the packaging for my application for a release and replicated. But then in the smoke test here that we're running, or this would likely be a more robust release test that you run instead. But this matrix here isn't just being generated from a hard-coded list of versions that I defined like I did for the development workflow where I used kind 125. In this case, this is being populated by the actual customer instances that I have for my application. So I can go over to my customers page here and see that, and this isn't contrived anyway, this is really what's happening. I'm running this against these customers. So I have, for my app, I have a customer on AWS 127, customer on K3S 126. So if I go back to my workflow that kicked off as a part of the creation of that tag, it looks like it finished, which is great. This kicked off two jobs: Compatibility Matrix K3S 126, EKS 127, which are the exact two distros and versions that my two customers have. So we got those instances, we fed them into the Compatibility Matrix, we ran our tests, and then we automatically promoted to the stable branch because we know we've got confidence this really worked. Like, this release is going to work on our customer representative environments, so let's ship it. And if I come back to my channels page, I can see that 0.0.20 release got promoted to stable automatically because of that successful test run against those customer representative environments. So coming back to that, I want to mention real quick something about Helm installation. So this is another thing that we're working on here at Replicated to not just enable you to use COTS and curl and some of the tooling you're familiar with. That is certainly still a part of the platform. We're continuing that, but we're also working on the ability to deliver via Helm. So if you have a customer, let's say, who just wants a Helm chart and you want to deliver your app to them directly via Helm, we have support for that. So from a single release, you can use COTS, curl, Helm CLI, and deploy your application to your customers however they see fit. And something that we've added as a part of this is a new SDK that you can include as a subchart of your Helm chart. And that SDK provides instance insights for apps that are delivered directly with Helm. So even though COTS isn't in the picture in this case, if you include this SDK, you'll get that same instance insights information that we showed a minute ago for these customers as well. So that not only is going to help you track your adoption rate and things like that for customers, regardless of how they're deployed, it's also going to be helpful in the compatibility matrix because you'll be able to say, for Helm installed customers, I want to run a Helm test on these environments because you have all of that data as well. And if you look back at my example here and the customers that I had here, I had one that was on COTS and one that was using the SDK and Helm. So again, that Canary test actually did a Helm install on the EKS cluster, and it did a COTS install on the other cluster because I have customers that are using both of these options. And the great thing about the Helm installation and the SDK is that it only takes 4 lines of YAML to make it happen. So I can declare the replicated SDK as a dependency of my chart, and I get all of this instance insights totally for free. There is nothing else except for these 4 lines of YAML. So how does that work? Let's look at a quick little flow chart here. So you've got your Helm chart. You put the SDK in there as a dependency, and then package this up as a replicated release, just like you always would. Promote that to a channel in the vendor portal, and then the vendor portal sees that there's a Helm chart there, so it's going to push that chart to the replicated registry. So now it's in the registry so that your customers can pull it and install it using the Helm CLI directly. To do that, your customers from their environment need to log into the registry, because our registry provides license authentication for the charts. So your customer has to have a valid and unexpired license in order to log into the registry to pull the chart. So you get authentication at the registry level. And then when your customers perform a Helm install, the registry knows who they are because they've logged in uniquely using their license ID. I forgot to mention that. The registry login command uses their license ID to tell us who they are. So we're able to inject customer-specific values into the chart so that when Helm installs your application and the replicated SDK, the SDK gets initialized with that information about the customer, which allows it to start reporting back to the vendor portal, hey, I'm running on an instance that's on this version of Kubernetes, this distro, this version of the app. It's a Helm install method, etc. So that's basically how that works. And this not only broadens the ability for you to deliver to different customer environments, but all of that is integrated back into these new services that we're providing to you, like Instance Insights and Compatibility Matrix. So if this has piqued your curiosity, if you're interested, if you know my testing could be better, I want it to be more automated, I want to test on increasingly customer representative environments, then please let us know, because we're actively looking for vendors who are interested in using Compatibility Matrix and testing it out and working with us. We're happy to help you to onboard and do whatever work is necessary to get this integrated into your environment. Like you saw, it's just a few lines of YAML you need to add in and sort of maybe combine with whatever other stuff you might have in your CI. But we're happy to help as much as possible to get that working for you, just in exchange for some feedback from you to learn more about it. And the great thing is that your input can even help to shape the roadmap and what we prioritize next based on what your testing scenarios are and whatnot. So that's it.